Oh man, was that fun. Oh, I can't believe how accurate some of you guys are with trash ball. Well, anyways, sorry if you're just joining, you missed our trash ball tournament. We're going to get started right away. I don't think I'm going to get all of 7.2 done. It's really pretty short, but we'll try and get it done in 15 minutes. If not, we'll get another video in. 7.2. We are sticking with proportions, all right? Remember, we deal with two types of problems with inference. We deal with means, and we deal with proportions. And pretty much from here on out, the first section will always be proportions. The next section will be about means. So 7.2 is on proportions. 7.3 is about all means, so averages. And so just kind of to show you, I've got a website that distributes Reese's candy, and so it says, let's make a couple graphs. One where we sample 25. So basically, I'm going to open up a pack of Reese's peanut, whatever they're called, Reese's Pieces. That's size 25, right? And then I'll open up a pack over here of 100, and we'll kind of compare to see, you know, like what it looks like. So here we go. Let's do the graph first to 25. All right. So right now I'm setting the probability of orange at 50%. I don't know what it is really, but number of candies. So let's say I open up my pack of 25 candies. What are the odds they're orange? Now, am I always going to get 50% orange? No, right? You know, sometimes they'll be kind of intermixed. So I'm going to take one sample. That means I'm going to open up one bag. And if I do this, so here it is. I'll pull out 25 candies. And out of 25 candies, it says 13 are orange. Well, that's almost 50%. Oh, by the way, let's make sure this is a proportion. Okay, so that's almost 50%. It's about as close to 50% as we can get, right? If I was to draw another sample, I might not get that. I might get a completely different. Let's see how many orange are drawn here. Ooh, 56%. So that one's a little higher, right? And if I just kept doing this over and over and over, right, drawing different samples, I would get another dot in here. And now just slowly start forming what we call the sampling distribution, all right, with ing. So skip to the chase. I'm going to do 100. And I'm not going to animate this baby. It's just going to show up. So I'm going to do 100 bags and see. All right. So there should be 100 dots underneath this curve. All right. So there we go. So notice, all right, when I do 25 candies, I can have some variability, right? So let's describe what is the shape, center, and spread. So let's say the shape is approximately normal. Would you say for 25 bags that are 25 size? The shape is approx. By the way, never say normal unless you are 100% it is perfect. Always say approximately normal. Okay, so I'd say it's approximately normal. And since I'm writing on a mouse, I'm going to abbreviate a lot. So the shape's approximately normal. Where's the center at? Ooh, let's see. The center looks to be around 48%. So center looks to be about 48%. That's kind of weird. Center's at 0.48. And how would I write my symbol for this, right? Well, it would be the mean of all my samples, right? Mean of all my samples. Okay. And what would be my spread? So how far out do I go? What do you think that is? That's about like what, 28? All the way to about 75%? So from like 28 to 75%. So from 0.28 to about 0.75. This is a rough estimate. Now remember, this is only 100 different samples. The sampling curve would have, you know, thousands and thousands and thousands of samples. Why don't we just up the, I'm just kind of curious. What if we do, well, let's go 10,000. 10,000. 10,010, sure. Let's see how this is going to change. Just curious. All right, yeah. Now we're looking at a sender a little bit different, but yeah, it goes out to, it's a little wide. Okay, so now how is that different with if we take 100 samples now? So let's say we up the size and we're ripping up a bag of 100. All right, are we going to be closer to 50%? What, you know, what do you think is going to change? Do you think it's still going to be approximately normal? Do you think the center is still going to be around 0.5? Do you think the spread is still going to be about the same? Let's check this out. We're playing here. So now I'm going to use number of candies. All right, so I'm going to do 100. So just to relive the glory days, right? We're going to actually animate this. So they're going to draw 100 candies. You know, and we're going to see roughly how many would be orange if we just randomly draw 100 candies. And 100 candies. Here we go. Orange, 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 orange. Ooh, 56 orange, right? So it is possible to get 56, right? And that's just 1 point on our graph. Let's do this 100 times. I'm not going to animate it because that takes forever. And here we go. Boom. You know what? I'm going to do it 1,000 times. Just because that looks skewed. And that's not what it should look like. Alright, there we go. Alright, so what do we notice about this? Okay. Well, when you take size 100, you take a sample that's size 100, center is still going to be around 50. So shape is going to be normal, approximately. Right? Yeah, I'm definitely not getting approximately normal. The center. Well, the center is still the center of all those samples, those 1,000 ones that I did it 1,000 times. Center is around 50%, right? That's all about the same. Let's check out the spread. Check out the spread, baby. What do you notice? Well, the low looks like it's at about 32. And the high looks like it's about 50 or 67. So 32 to 67. Okay, so what has changed? Well, the big daddy is this, right? And we talked about this yesterday a little bit, right? As you have larger numbers in your sample, your variability slowly shrinks, right? So if you only do 25, you have a lot of variability, right? I could randomly get a lot of orange somehow. But when you get up to like 100, if I was to do 1,000, all right, how much variability would you think? Let's do 1,000. So we're going to open up a bag of Reese's Pieces that contains 1,000 Reese's Pieces, all right? And if I was to do that obviously once, you know, it'd be just one, but let's do this 1,000 times too. So we're gonna open up 1,000 bags. 1,000 bags with 1,000. All right, come on, baby. You don't really need to animate it like this. There we go. That's what it looks like. Notice the spread is a lot smaller. This one goes from like 44 to 55. Notice the spread. Center is going to be the same, roughly normal, but the spread is just different, right? And as we just keep going up, I mean, if I open up a bag of 10,000 candy bars, or 10,000 candies, and I did this 1,000 times, I don't know. Are you guys kind of understanding what's going on here? Here we go. So a bag with 10,000 Reese's. And let's see how long this takes to calculate. This could take a while. I'll be right back. Well, anyways, I waited for a long time and it wasn't done rendering, so we're not gonna wait. Hopefully you get the hint. The more samples, the skinnier your graph gets. All right. So remember, for specific p, the standard deviation gets smaller as n gets larger. So as you sample more or a larger amount, that ways you can sample gets smaller. Okay. Here we go. Important stuff. This is probably the most important page right here. Okay? Basically, the mean of the sampling with the ing distribution is going to be, so the mean of all the ways I could sample will actually equal the true percentage. Notice how, remember on that curve, those curves, I had it set for 50% orange, and all the ways I could sample kind of bounced around on both sides of that 50, and the highest point was at 50. Standard deviation. All right, now this is a little bit trickier because you haven't seen this yet. New formula for standard deviation. If I want a sampling distribution, my standard deviation gets smaller as n increases, right? We just talked about that, right? So if I do 25 candies, it's going to be this big. If I do 100 candies, this big. If I do 1,000 candies, this big. If I do 10,000 candies, it'll be this big. So it gets smaller depending on our sample size. So this is the formula for standard deviation. Now remember, this kind of looks like, remember the formula for standard deviation before was n times p times 1 minus p. Okay? Basically what this is kind of turned it on its head so that this way this will be making the standard deviation smaller by dividing it. So depending on my sample size, the standard deviation will change. Okay? So you got to remember this. Now here is the last rule that you need to memorize for proportions. Okay? First of all, as long as the 10% condition is satisfied, remember 10% condition works, or independent, maybe we'll call this ND, right? Remember, because things have to be independent, all right, for this formula to work. 10% condition, we talked about this yesterday. But then notice this. As n increases, the sample distribution becomes approximately normal. All right? Notice, we had a normal curve, right? As n increases, it gets more normal, more normal, more normal. All right, before you can perform calculations, or before we can start doing like z-score stuff, because z-score stuff works on normal curves, right? Before we can do that, we got to make sure it's normal. Now, here is the test, all right, if it's normal. All right, we're going to have to write this down. There's the formula, all right? You've got to do both of these to see if it's normal. Now, in short, my next slide will summarize this. I think formulas are a little hard to memorize. You need to have, what these formulas say, you need to have 10 successes. So in our case of Reese's Pieces, you need to have 10 orange, and you need to have at least 10 failures, or 10 of different colors, right? That's what this means. 10 successes, at least 10 successes, and 10 failures. All right, so if we were, remember we were doing the trash ball, and we had to shoot until we had 10 successes and 10 failures, therefore we knew it was normal. Okay? Only have one more minute, and I haven't even done math yet. Okay, so here we go. Last thing you need to write down for proportions. You must know these three. At least 10 successes and 10 failures is the normal test. Just told this out to you. So we should have a random test. How do we know if it's random? It's random. How do we know if it's independent? We have to have less than 10% of the population. And how do we know if it's normal? We need at least 10 successes and 10 failures. So there is a fine line between here and here, right? This is my max number that I need to that I can sample from, and this is my min number that I can sample from, right? So I got to find that sweet spot. Okay, tune into the next video. We're going to do some math. We're going to do some z-scores. Write this down.